All right. So we will start from question 8. Okay, question 8 here. Let's look at the question 8. What is this? This is about volume and surface area of a 3D figure, right? Three-dimensional object now. Draft is in the form of an open rectangular box. It's a 1.85 meter long, 45 cm wide, and 28 cm deep externally. Okay, if the draft is made of wood, 2.5 cm thick, 5 in cubic centimeters, the volume of the wood required. How much wood required first? Okay, how do you calculate the wood required? There's, of course, you can break up in small pieces and find the volume of the wood there. Thickness is 2.5 cm. Or you can take the big, let's say the wood contains water here. So you can actually take the big one. So actually you take the big one here. So let me draw it here. Big one. This is the big one first. External. So this is 1.85 meter. This is 45 cm. And then this is 28 cm. So the problem is because they are in different unit, you must convert to cm. Okay, I want to cm now. So 185 meter is 185 cm. Okay, just the external. So what you can find is the volume of the external one. Okay, because we want to find in cubic the volume of the wood required. So what you need is actually find the volume of the external box, the external box. Okay, external draft. Okay, volume of the draft first. Box, external box, better say volume external box here. So this one is actually, you find out is actually 185 length times width is 45 times height is 28 here. So then you calculate the volume of the external box here. So it's a big number. Okay, so okay, let me see. Okay, let me see. Something wrong there. My calculator. Okay, good. Calculator there. So 185 times 45 times 28 is a big number. 233,100. Okay, this is a volume big number. And then now you calculate how much is the draft contain. Okay, so it say that this draft contain has made of wood 2.5 cm thick. So if we go inside, basically that means that you want to find the thickness, right? Of course, you find the thickness. Okay, let's try to find the thickness here. So volume of the internal box. Okay, internal box. Okay, let's see how internal box is. Okay, so you have to go inside. How to find the internal box out, because the you have to go in 2.5 cm. So that means you have to go in 2.5 cm. So actually you go in 2.5 cm. So on this thing 2.5 cm, also 2.5 cm. So altogether is 5 cm, right? So you take 185 minus 5 cm. Okay, this is actually 185 here. Start from 185. Okay, 185 minus 5 cm. Okay, 2.5 times 2 is 5. Okay, 185 minus 5 cm. This is for the length. Okay, you also have to find the width. The wood is 2.5 cm, so you have to go in 2.5 cm, 2.5 cm here. Right, so the width now is 45 minus 2.5 cm times 2, which is 5 now. Okay, 2.5 cm. Then the height. Okay, this is an open rectangular box. Okay, open rectangular box means there's no top, no cover up or no top. So, but you need 2.5 cm from the base. So you need to go up for the thickness here, 2.5 for the base. So that means you need 28 subtract 2.5. Right? But top you don't need to subtract because the top has no cover. So now this is actually 180 times 40 now times 28 minus 2.5. Okay, so it's 25.5. So multiply all this together times 40 times 180 is 183600. Okay, so how much wood is required now? Volume of wood required, you can subtract them. Okay, so you want to find how much wood is required. Okay, I mean the wood here. This is the wood here. Okay, these are the wood here. The wood here. How much wood required after you cut the corner 2.5 cm, right? So the wood required, amount of wood required, the volume of wood is just take these two difference. Okay, 233,100 minus 183600. Okay, take out the difference. Okay, this one, subtract this one here. So we get 233,100 minus 183600, and then you get 49500. This is amount of wood required, and this is in centimeter cube. Okay, so this is how you do question 8. Okay, it's actually how to find the volume of a box. Okay, cuboid, we call it cuboid here. So take a different of an external box and internal box there, which I can fill up the water for whatever content. Okay, then you can find the volume of this thing. So I can WhatsApp this to you here. Okay, the question 8 here. Okay, this is what we learned from yesterday, how to find the volume of the cube. cuboid. Okay, volume of cuboid is the base length and width of height. So in this case, what you need to do is find the difference between internal one and external one. You can find the volume of the wood required. Okay, so this is question 8 here. See how line is not here yet. Okay, what is Warren? Okay, I don't know what happened. So Ryan was there just now. Okay, so let's continue, right? So sometimes people disappear. Okay, number 8 I finished early. So I go to number 9 now. Okay, number 9, a hollow metal sphere. Internal diameter is 8 cm. External diameter is 12 cm. It's melted down to be cast into a solid cone of base radius 6 cm. Calculate the height of the cone. So you start with a sphere first, metal sphere. Diameter, internal diameter 8 cm. So we have a sphere first. There are two spheres actually. One inside, one smaller, one bigger one. So I can put there, inside there, two spheres. Right? So the inside diameter is 8 cm. Diameter inside is 8 cm. And the diameter outside is actually 12 cm. Okay, this a hollow sphere. The hollow sphere, that means that inside got nothing, right? Hollow sphere, so this is hollow sphere. Right, hollow sphere. So inside got nothing there. So what is the volume of the hollow sphere? We try to figure out first. Okay, volume of hollow sphere. So let's try to find the volume of hollow sphere, right? So you find the inside volume of hollow sphere. So you take the big sphere minus the small sphere, right? Then you get the volume of hollow sphere. What is the formula for a sphere volume? Okay, this one is pi 4/3 pi r square. The outside volume diameter is 12, so 12/2 cube. Okay, volume of space 4/3 pi r cube for a sphere. So this is outside bigger sphere. You minus the inside because it's hollow. So minus inside here, which is actually 8/2. Right? Diameter is 8 now, so you divide 2, you have radius power 3. So you find the volume of the hollow sphere. Okay, so that What is actually, we take the outer sphere, bigger one, subtract the inside lower sphere, the smaller sphere, and then you see what is this, right? So calculate the volume here is actually 6 power 3 first. Okay, 6 power 3 minus 4 power 3. Okay, 6 power 3. Okay, then minus 4 power 3. Okay, then afterward multiply by pi. Okay, then multiply by pi. Then multiply by 4 over 3. So this volume here, 636.7. Okay, I think 61.7, and this is cm cube here. Approximately 636.7 cm cube here. This is volume of a sphere. Okay, so to find the hollow sphere, volume of a sphere now. Then what happens if this melt down? Okay, it's melt down to be cast into a solid cone. Base radius is 6. So what does the cone look like? The cone look like, okay, you can draw this. A cone look like this. Right? So we melt down. Okay, melt into a cone. And what do you say about cone here? The radius is 6 now. So this cone here, radius at the base is 6 cm. So what they want is find the height of the cone. Find the height of the cone. Height of the cone, huh? So height of the cone is what here? The height of the cone is this one. Okay, this is height of the cone here. So you draw it right here. Okay, so the cone comes from the sphere, the hollow sphere. What is the volume of a cone first? We have a formula for volume of a cone. This one, you can check the formula. Volume of a cone. Let me see volume of a cone here now. Volume of cone is equal to 1/3 pi r squared times h. Okay, 1/3 pi r squared times h. This is the one is a sphere here. On top is volume of a sphere. Okay, volume of a sphere is on top here. Now the volume of cone now. Okay, cone is even less familiar here. So 1/3 pi r squared times h here. And this comes from the hollow sphere. So we know that this is equal to 636.7. Now, okay, you put it in here. So this answer 636.7 you put here now. Okay, because this thing going to be cast into the cone. So what is h here now? So h is equal to, rearrange them, is 636.7 3 over pi r squared, where r is 6 now. Okay, r equals 6 here. So I can find the height of the cone by using this. So you get 636.7 times 3. then divide by 36, because 6 squared is 36 here, and then divide by pi is 16.88, so actually 16.889. Okay, so I could say 16.9 lah, huh? 16.9. Okay, 16.9 cm. So this is how you do the question 9. You have a sphere, so you need to find out what is the volume of a sphere, formula for a sphere, and then you volume of a cone is another formula, right? Volume of a cone is this formula. Then you rearrange them to find out what is height here. So this is actually question 9. Okay, if you have not watched the lesson yesterday, you'll be quite lost, because I think a lot of formula is new to you. Okay, so I recorded lesson for this purpose for those who have not went through it yesterday. Okay, so let's try some more. Okay, and then the last day, and some of the students from yesterday, make sure you watch a video, because some of you are here now suddenly. Yes, Ryan, Jason, Sivakuma, beginning the year. Okay. Those who weapon, I say, I'll just go out. That's a weapon. So, yeah, okay. Okay, so I have went through the question, okay, on question 9. So now I move on to question 10 already. Okay, question 10 is a cone again. Okay, find the volume and the total surface of the solid with conical ends as shown. So there are two things we need to find. So a bit more things to find out. Volume of a cone. What is volume of a cone, right? And then total surface area. Okay, this will be quite new to you. Okay, how to find the volume of a cone. So look at this picture here. There are actually two cones, right? The radius, the diameter of a cone is 12. So you can look at this, there are two cones there. Diameter of a cone is 12. So this is 12 here. The diameter of a cone is 12 cm here. And the slant height is 10. So let me try to draw a triangle. What is the volume of the cone? Look like this. The volume of a cone, just as I mentioned this, is 1/3 pi r square h. Okay, 1/3 pi r square h. So where is r? R is equal to 6 now because this is 12 here. So this is 6 here, and then this height here. Okay. We're given this information. So you draw the particular terms. What is, you know that given is 10, r is equal to 6 here. So let's try to figure out h first. So you draw a triangle. As I say here, this is triangle here, triangle. This 10, this 6, this h here. So what is h in this case? So we know that 10 square is equal to 6 square plus h square, triangle. So that means that h square is equal to 100 minus 36 now, because 6 square 36, right? And then h square is 64. 100 minus 36 is 64. Then so h equal to what? 8 cm. So you find out the h is cm already. Okay, so h is 8 cm. So volume of one cone is 1/3 pi, r is 6 square, h is 8 here. So this is actually okay, 36 times 8 here, then divide by 3, then times pi. Okay, this will give you 301.56 here. Now this is just volume of one cone, but they actually two cones are stacked together. So volume of this solid now, okay, volume of solid is two cones together, one upper, one lower. It's actually 2 times of this. So times this 2, and you get the volume of cone is 603. Okay, this is how to find the volume of cone. Okay, let's concentrate on the volume first. Okay, so there are 2 cones there, one on top, one below. So now I have found the volume of cone first, which is 1/3 pi r square times h here. But you need to find out h here. Okay, this to find h here. Okay, to find h here. So the h and the 10 here, just remind you, some people maybe was not in the class yesterday. This 10 here we have named for this. This 10 is called the slant height. Okay, this 10 we have named for this slant height, and h is the height here. So this is the height here. Okay, so in order to find the volume of cone is 1/3 pi r square times height. So you need to find the height here. So this is question 10 part 1. Okay, so copy this thing to you. This is part 1. Okay, then I want to find part 2 now. Okay, part 2, find the total surface area. This is something new again. Total surface area. How to find surface? There are two surface area there. Okay, in this case, what you need to find is the surface on the curved surface only. Okay, so curved surface only. I insert here. So let's try to get this. So you want to find the curved surface area, right? So what are the surface area? It's actually this one. I just draw this one for you first. So the surface area is the one when you say this is a 10 slant height here. Okay, slant height. So when you open up, so let's say you open up this one, you cut it open. Okay, cut open. Then this is a V here. Then it will look like something like this. When cut open and open up, this one look like a fan, right? Like a fan here. Okay, then this part is 10. Okay, when you cut open, it look like this. This is a curved surface area, right? The curved surface area. Now the formula for curved surface area, which is equal to the formula this one. Yesterday I mentioned this is pi r l. R is the radius on the base. Okay, there are actually two surfaces, one of them on top, one on below. Whereas the base area surface don't need to count because it's concealed invisible surface, alright? So there is an invisible surface to need to calculate here. So this surface invisible here. Okay, this is invisible because we don't see this surface. So only the curved surface you need to calculate. Curved surface is pi, formula is pi r l. L is the slant height. L is L here. Okay, slant height. So this is pi r is we find out this is actually equal to 6, right? Radius 6 here. 6 L is 10. So 60 pi. So there's 60 pi here. And this is 188.4. Or 188.5, Okay, this is just the top one, right? There's another bottom one. So total curves surface area now 2 times, okay? Total curve surface area, one on them top, one on them below, is 2 times of this thing. 2 times of 188.5. So times 2 here. Okay, this will give you 378, 377 now, okay? 377 cm squared. Okay, this is how you find the total surface area. Okay, total surface area. So we are looking at this one. So there's a formula for total surface area, curved surface only in this case. So the formula is IRL for a cone curved surface area. IRL is this one. Okay. This is the one. When you cut it open, it looks like a fan. Okay. And this is your V here. The V is here. Cut open, look like a fan there. Okay, so this is the second part of question 10. So I can WhatsApp this to you. Okay, let me see. Right? Okay, now I move on to the next question now. Okay, question 11. Okay, you see the different shape put together now. That house is in the shape of cylinder, surmounted by a conical roof. The cylinder has a radius 3.5 and the height 4 meter. The conical roof has the same radius, same as the cylinder, and the height 1.2. What we want now is find the nearest dollar of cost painting the outside of that house. Okay? Outside of that house, right? Painting the outside of that house. If actually, what are you looking for now? If the cost is $2 per meter square. Okay, outside of the house, so including the roof and the door, everything must paint. The only thing you need to paint is the inside. Inside nothing to paint here. Okay. So what is actually looking for is the surface area. Okay. Because to paint something you need surface area here. So actually looking for surface area. Okay, there are two surface area to think of. One of them is a cone. Cone, the surface area of the cone without the base, all right? Just want to, so in this case, you just want to curve surface area. So this phone looks something like this. The height is 1.2. The radius is 3.5. Okay, this is slant height here now. So this L. So R equal to 3.5. H equal to 1.2. And this one is called L here, slant height. Okay, so let's calculate the slant height first, then you can find the curved surface area, right? So slant height is equal to right angle triangle here, R square plus A square, which is equal to 3.5 square plus 1.2 square. So calculate this one is 3.5 square then plus 1.2 square, then take the square root. Okay, 3.5 square plus 1.2 square, then take the square root of this answer. You get 3.7. Okay, 3.7 meter. Then, so the total curved surface area, total curved surface of cone. The formula is pi RL. Okay, total curved surface is pi RL. Okay, you don't need to calculate the base because base is actually not the outside surface area. Okay, so as pi RL, you get pi times R is 3.5, L is 3.7. So this is actually multiplied out here. Okay, 3.7 times 3.5 times pi. Okay, this will give you 40.68 here. Okay, so this one is curved surface of the cone, area pi RL formula. Okay, then there's a cylinder. The height is 4. And the radius is 3.5 again. So I want to find the curved surface area, right? Now, curved surface, so again, you have to, just like just now I say curved surface area is like a fan, okay? If you cut open, get a fan, something like this. Okay, fan. So you cut it open, get a fan, this area. Okay, this is L, 3.7 now. For a cylinder, you also can do this. You cut it open. And then you're going to get a rectangle. The height is 4. Then the length of this one is 2 pi r. R is equal to 3.5. Okay, so area of this side curve area here, right? So total curve area here for cylinder, total curve area of cylinder. Okay, these are all the outside area here is equal to 2 pi r h here, 2 pi 3.5, h is 4. So you get, okay, 2 times pi times 3.5 times 4, you get 28 pi, which is 60, that is 87.9, so 88, okay, 88, this is meter square. So total surface area is equal to what? So you can calculate here. Total surface area for total surface area line is equal to 40.68 plus 88 here. So we multiply together 40.68 is 128.64. Okay, but this is not the answer we want. You want the cost of painting the area. It costs $2 to paint out the area here, $2 per meter square. So the answer in this case just times 2 here. So take the answer 128.64. Okay, you take these two areas together. So this is this one and this one put together times 2. Okay, so you times 2 here, you get $257. Okay, $257. Okay, I say $2.7 about that. Yeah, which is 2.7.2 lah. Also have 2 here. Okay, 2.7.2. Slow. About that lah. Or 3. Okay, depend on how you round up the figure here. Okay, 3 there. So this is the answer for question 11. Almost finished the last question already, you know. I'm going to finish this one. Okay, I don't know why Sarayan 17 is here. Okay, now the last question. Question 12. Okay, so question 12. A triangular cross-section of a center back bunker has a side of 4, 3, and 2 meters. If a bunker can hold 30 meter cube of coal, what is the length of the bunker? Oh, this one is very easy, right? So first of all, you look at triangle. Triangle, they tell you that this triangular cross section. This bunker look like this, so you can draw a triangle here. So the triangle and the triangle are not the even type 4, 3, and 2. So this is actually one side is 4, so 3, 2, right? So let me try to draw it more realistic there. It's 4, 3, 2. Okay, triangle there. Not necessarily right angle, it's not, I don't think it's right angle here. So this is triangle. And then this is just a cross section only. Okay, side, okay. And then this triangle has, you want to find out, you put it, okay, let me try general triangle so that you can see the picture here. Although it's not very realistic, but it's easier to draw. 4, and then 3, 2. Okay, so this cross section here, now you extend it, become a 3D figure now. Okay, 4, 3, and 2. And the volume of this thing can hold 30 meter cube of coal. So volume of this, this thing is called triangular prism. Okay, volume of triangular prism is actually, what is the formula for this? It's base area times height. Okay, and this is happen to be 30. Okay, 30 happen to be 30 here. Okay, base area times height. Okay, what is the base area? Area is a triangle here. So area triangle, it is area of triangle here. Okay, times height. The height you don't know. Okay, or the length. Okay, find the length of the bunker. It's the height here now. Okay, area triangle, how to find? Remember, there's one formula for area triangle given three sides here. Is S equal to half of A plus B plus C. The length of three sides is 2, 3, 4. So actually, 2, 3, 4. Okay, which is 4.5 now divided by 2. Okay, 4.5 cm here. So 2, 3, 4. Then area of triangle now. The formula for area triangle, this one, the fixed formula, is actually S times S minus A, S minus B, times S minus C. So A, B, C are 2, 3, 4. Okay, so this is actually 4.5 then 4.5 minus 2, 4.5 minus 3, 4.5 minus 4. Okay, so that's final answer. So this is actually 4.5 times 2.5 times 1.5 times 0.5. Okay, take a square root of this number. It'll give you 2.90. Right? 2.905 or 2.90 enough. Basically, it's 2.904. So that means I can find the height now, which is also the length of this bunker here. So height is the length here is equal to 2.904. Okay, this area of triangle we find out here is 30 here. So the height looking for is 30 over 2.904. So get 30 minus over this, right? Okay, times 30. It's 10.3 or 10.3 now meter. Okay, so the height or the length of the bunker is actually 10.3 meter. Yeah. Okay, look at the answer. Answer is 10.3, right? Yeah, correct. So that is how you interpret this question. So this triangular cross section of a saddle bed bunker. Okay, three side 4, 3, 2. Then you can find the base area triangle, and then you can find out what is the height here. So this is how you do question 12. I'll send this to you. Okay, so I have shown you how to do question 8 to 12 already. And that is all I intend to do for this tutorial. Okay, now next week, so next week is actually I'm going to do revision already. Okay, next week I'm going to do revision. What I do revision here? Let's see what you need to do for revision. Okay, where can you find it? I'm going to share with you how to find revision. I think go to Blackboard is so back here. So I'm going to share with you how to find a revision here. So I'm going to share with you now. So let's stop recording me. No, really. Just okay, naturally. Okay, so still people absent here, right? Okay. So I'm going to share with you the where to find the division paper, right? So I think where is it? I think it's okay, this one. Okay, I share with you. So you go to learning resource. Okay, then you look for there are many things inside there. So look for division. Okay, let's see. There are a few one. Okay, there's a division for exam. So where is it? Okay, here there's a sample exam paper for practice only. Okay, sample exam paper for practice only. So you download, open the disk. I'll show you the picture here. Sample exam paper. You can try it yourself first. Okay, try it yourself first. See how many you can answer. Okay, every year, maybe the question B part C, don't need it. Maybe part C don't need to worry because it's different question. Okay, I'll try to update the question for you. A, B3, A, B are okay, but C I think maybe it's not suitable because this is a hyperbola already. Okay, I'll update for you and then give you more simpler question. And then, okay, basically you have a exam, same thing. They are multiple, there are 5 multiple choice. Okay, then 6 question, written question. Okay, 5 multiple choice and 6 written question. So for this question, actually only B3 part C is not suitable. Okay, B3 part C is not suitable. The rest are suitable question. But okay, if you don't know how to do this question, okay, you do it for yourself first. Then I can actually talk about how to solve this. Okay. So this is a paper I'm trying to go through with you, right? So that will be all for today. So I think stop recording already. So I stop recording.